Hello friends, welcome to HP Web Academy. In this particular lecture, we will discuss about the principle of virtual work. So let's start our discussion. So what is the principle of virtual work? If a body or a system is in equilibrium under the application of many forces, okay, then sum of all virtual works, okay, we will define what is virtual work, done by all forces, done by the virtual displacement of their point of application must be equal to 0. So let us mark the keywords here. So we have the keyword as virtual work, okay, done by all forces due to virtual displacement. So we have the keywords as virtual work, virtual displacement of their point of application. Okay, so three keywords are there. So virtual work, virtual displacement and the point of application. Okay, so let us consider a rigid body like this. Okay, rigid body. So we have four forces acting here. Okay, so all these forces are acting at the point of application. So our point of application is, let us consider this point of application as 1. Point 1, this is our point 2, this is our point 3. So this red marked portion is point of application. So this is point 3 and this is point 4. Okay, so we have sum of all virtual work done by all forces. So the forces here are F1, F2, F3 and F4 due to virtual displacement of their point of application. So these are the point of application, point 1, point 2, point 3 and point 4. So the force F1 is acting at point 1. This is the point of application. F2 is acting at point 2. F3 is acting at point 3. F4 is acting at point 4. Okay, so let us discuss this in detail. Okay, so let us go back to the definition of work done. Okay, so we have work done. Okay, the work done is force times of dot product of force and displacement. Okay, so this we can further write as, this is dot product, this is FD cos theta. Okay, so this is force times of displacement. This d cos theta is displacement in the direction of force. Okay, and this is the force. Okay, so this is, now let us see when the work done is positive or when it is negative. So work done, it is positive, and when displacement is in direction of force. Okay, if the force is in this particular direction and displacement is also in this particular direction, then the work done is positive. And work done is negative when displacement is in opposite direction of force. Okay, suppose force is acting in this particular direction and displacement is in this particular direction, then the work done will be negative, and it is positive when the displacement is in the direction of force. Okay, so now let us compare. So we have the real work done, and we have virtual work done, Okay, so let us compare this. So in case of the real work done, we have the components as force and displacement. So let us write down here this force, and we have one component as displacement. Okay, so in real work done, this force is actual force and displacement is also actual. Okay, and in virtual work we have force and displacement. Okay, so in case of virtual work, we have this force is actual, that is real force is acting, but the displacement is imaginary. We just imagine that the displacement is happening. Okay, imaginary. In actual there is no displacement, but we imagine that there is some displacement. So based on the force and the imaginary displacement, also known as virtual displacement, the work is done, and that work is known as virtual work. Okay, so now let us go back to the figure. Okay, so we have considered a rigid body and four forces are acting at the respective point of application. So at point 1 we have F1, at point 2 we have F2, at point 3 we have F3, and point 4 we have F4. Okay, so let us consider the displacements. Let us consider the displacement is in at point 1, the displacement is in direction of, let us consider this as ds1. This displacement is in the direction of force F1. Okay, at F2 we have displacement is in the opposite direction of the force, this is ds2. Similarly for F3, the displacement is in the opposite direction, this is ds3. Okay, at point 4 we have displacement is in the direction of force F4, so we have ds4. So we have the virtual work done. Let us write down the virtual work done. The virtual work is equal to force times of displacement. So this is F1 times of ds1, and it is the work done is positive because the displacement is in the direction of force F1. Displacement is in this particular direction, so this is F1 ds1. Okay, now at point 2 we have the displacement is in the opposite direction, force is in this particular direction, so displacement is in this particular direction, so this is negative, this is minus F2 ds2. Okay, at point 3 it is in opposite direction, so this is negative, F3 is ds3, F3 times of ds3. And at point 4 displacement is in the direction of force, so this is minus of F4 ds4. Okay, so this is the virtual work done. So based on the principle of virtual work, let us recall that if a body or a system is in equilibrium under the application of many forces, the forces here are F1, F2, F3, F4, then the sum of the virtual works, so these are the virtual works. Okay, these are the virtual work and this is the sum of the virtual work by all forces due to the virtual displacement. The virtual displacement as ds1, ds2, ds3 and ds4 of their point of application. The point of application is point 1, point 2, point 3 and point 4 must be 0. So this virtual work is equal to 0. So these are the sum of the virtual work. These are the virtual works at their point of application. Okay, these are the virtual work. This whole sum is equal to 0. This is known as principle of virtual work. Okay, so this is all about the concept of virtual work. In next lecture we will discuss about the problems on the virtual work. Okay, thank you.